All right. Welcome to Tuesday. We're into our second week now of our unit on climate change. And so at this point, you have been going through some work on climate change and weather. That climate is a very long-term series of events. It's trends and patterns. So when we look at things like, well, what has the Earth done over the last 1,000 years? Is it hotter or colder? Those represent changes in climate. Changes in weather is, well, it was hot today, it'll be cold tonight, it'll be cloudy today and rainy tomorrow. All of those are weather events. And when we combine many weather events, we begin to establish the pattern of climate. And so if we think about, well, things are getting warmer, or maybe things are getting colder, because we don't call it global warming because there are actually parts of our Earth that are cooling. So we call it climate change instead of global warming. But with climate change, there's actually parts of the Earth that are getting colder, and there are parts that are getting warmer. So as we think about climate change and weather, and we understand why the sun is putting out lots of energy, lots of heat energy, that heat energy comes to our planet, and some of that thermal energy is getting trapped, which makes gas molecules and atoms move faster. That's the heat that we see. And that energy can be transferred. Remember, transfer versus transform, very different terms of energy. So with energy, we transfer that heat energy over to, for example, ice or water, and we can warm the seawater. We can warm the ice and make it change state. So how do we record and go back and look at, how do we know what the climate was a long time ago? Well, we can actually go back tens of thousands of years when we go and we start drilling ice cores out of places like Greenland and Antarctica. And so if you haven't had a chance to look at the blue ice cubes in States of Matter, you might do that, because that is about looking at very old ice with atmosphere bubbles trapped in the old ice. And so we can actually tell how much carbon dioxide was there many years ago. All right, I'm going to take one more look at our phase change diagrams again. Want to make sure that doesn't get away from you, because hint, when we get to our quiz coming up soon, we are going to be looking at a phase change question. So we start always with this graph that has temperature and pressure. So temperature always on the bottom, pressure on the left side, okay? And then phase change diagrams look different depending on the substance. So we might have one that looks like that, but they are always solid, liquid, gas. So if I put something on here like 30 degrees Celsius and 100 degrees Celsius, and I told you, well, a substance is at 5 psi. We'll do psi this time instead of atmospheres. 5 psi. And at a temperature of 30, what is the state of matter? And so you could just follow up and go, oh, it's a solid. So then if I asked a follow-on question, we're going to leave the pressure at 5, but increase the temperature to 50. What is the state of matter? And you go, okay, well, I leave the pressure the same. I go over to about 50. Yep, 50's about there. And it would be a liquid. Then I could say, okay, let's leave it at 50, but decrease the pressure to 1 psi. You go, okay, well, let's see, I can do that. That would come down to right there. and it would change into a gas. So we're just tracking the substance through different phases, different states of matter, as we increase, decrease pressure and temperature. All right, the next thing that we are going to work on is the gas laws, okay? And so I have made a video about the gas laws for you, how to do the calculations. They are just a set of word problems, and I know everybody loves word problems, but that's what these are. Let's see if I can switch over to that. There we go. We'll go on to the gas laws. So in the gas laws part of Canvas, you're going to find my video about how to solve these. So where it says click here first, that's where you go to get the video of me telling you about how to do gas laws. Okay. Then under temperature, volume, pressure, volume, there's some practice on doing gas law problems, and you're going to be able to actually do those down here. There is a lab on the center one that you need to do. Because there's only 3, I need you to do all of these. All right. All right, so it is headed for Wednesday. And so for Wednesday, I want you to start working on the gas law problems. We're going to solve a series of these together on Thursday, but there's probably, I don't know, 15 or 20 gas law problems in formative. Formative is what you usually use to do a lot of your math work. So you'll be going over that direction. I provided hot links on the lab practice. Show me your work as you're doing these, because I want to see how you're coming along, and do a bunch of those. Okay. The last thing that you should be doing, because now we're coming down to the end of our second week. Remember, it's going to be Wednesday, and then it'll be Thursday, Friday. So you should be now describing the current status, number 6 there, of the 2 indicators in whatever region of the world you had picked. Number 7, predicting the status in the future. And you go, well, how do I do that? Well, go back to some of the papers and go back online and just say, what is the expected climate in Germany, because that would be mine, in 500 years, or in the future, or distant future. Those might be keywords you could Google. And if you've picked weird areas, let's say that you had picked the northern coast of Norway, and you're going, I don't know, I can't find anything on it. Then look for similar things, because there's lots on like northern Canada, or northern Alaska, or northern Russia. So you may have to look for similar things if you picked a smaller country, or a country that's out of the way. All right, so that is what you should be working on Wednesday, working on your paper and starting to work on the gas laws. On Thursday, in our Zoom meeting, I'm going to be going through solving gas problems. It'll be an I do, we do, you do. So I'm going to do some, and then we're going to do some together. And then I'm going to ask you to get with your study buddy, and you're going to begin doing some together so that you get really, really good at it.